previous video, we established that the standard equation of a parabola is in the form of y is equal to ax squared plus bx plus c. All right. We knew that the a had to do with the vertical stretch or compression of the graph. So in other words, how wide or how narrow it became. The b had to do with working out our new axis of symmetry and then in turn our new turning point. And the c, if you remember, represented your y-intercept. Okay, now there's a new form of our equation that we can work with as well, all right? And that comes in the form of y is equal to ax minus p all squared plus q. All right. Now, if the equation that we had originally was y is equal to ax squared plus bx plus c, then how are we able to, what's the link, what's the connection between these two equations over here? Well, to get from our original ax squared plus bx plus c to this new form of ax minus p squared plus q, all we have to do to manipulate it to get it into that form is to complete the square with it, okay? Essentially, the two equations would represent exactly the same function, okay? It's just that we've just changed the way the equation looks and the variables that it represents, okay? Now, you'll notice over here that in your original equation, the variables we were working with was an a, there was a b, and there was a c, all right? Now, in the new equation, there's still an a, all right? So because these two values both have an a in front of it, they still represent the same thing. Remember, your a being your vertical stretch or your compression. However, the p and the q are now two totally new variables we're working with, and because they're not the same as the b and c, it means that they don't represent the same thing, okay? So please don't make the mistake of thinking that the q represents your y-intercept. It does not, because it's being represented with a different variable, okay? So in your original equation, the c does represent your y-intercept, but the q in this new format that we're going to work with represents something else, and that's what we're going to work out and establish is what does that negative p and that q actually represent when we're given it in this standard form over here. All right, but let's start right at the beginning. We are going to complete the square, and we're going to actually convert it from the one standard form into the other. All right. Completing the square, remember, is a very step-by-step process, and we're going to use this example of 2x squared minus 4x minus 6. The first step of completing the square is that if you have a coefficient in front of your x squared, you need to take it out. You need to divide each of your terms by that coefficient of x squared, and you need to remove it from the three terms and put it outside of the brackets, okay? So if I divide all three terms by 2, we land up with an x squared. I land up with a 2x and a minus 3. Okay, all three of these terms happen to all be divisible by 2. That doesn't always have to be the case. So you may sometimes land up with fractions inside that bracket, and that's okay, all right? Then what do we do with completing the square? We take the middle term inside your bracket. So we take that negative 2. We always multiply the coefficient of your middle term by a half, and you always square the answer, okay? So if I multiply negative 2 by a half, we're going to land up with negative 1, and if we square negative 1, we're going to land up with positive 1, all right? What do I do with that positive 1? Well, I take my equation of 2 bracket x squared minus 2x, and what I'm going to do is I'm going to give myself a nice gap between the negative 2 and the negative 3, all right? And inside that gap, I'm going to take this 1 that we've just worked out, and I'm going to add it in there, all right? But like any equation, you can't just add something to an equation because it's then changing the value of the whole expression. So we need to keep things balanced and make sure we're not changing the value of anything. So therefore, if I add 1 to the equation, in order to make sure I'm keeping it all the same, I'm going to subtract 1 as well, all right? And although that looks a little bit strange, I do agree with you. What we then do is I group the first 3 terms together, okay? The idea is you need to create a trinomial that you're going to be able to factorize, and then you can land up adding those like terms over there. All right, so that's the idea. So we're going to write it as follows. Y is equal to 2 bracket. Now this trinomial is going to factorize which is going to be x and x, 1 and 1, both of them are negatives, and that's going to add up to give us negative 4. All right. Remember the name, completing the square. You're wanting to get perfect squares over here. So those two brackets always have to be exactly the same when you're completing the square. That's just part of the whole deal. So therefore, it's going to be x minus 1 all squared minus 4. And we almost finished. The last step is to distribute 2 back into both of the terms that are inside your bracket. Okay, so what are we left with? Y is equal to 2 bracket x minus 1 squared minus 8, because 2 got multiplied to both of the terms over there. All right, now can you see how I've managed to manipulate it into the form of y is equal to a x minus p squared plus q? All right, perfect. So we've taken what we had originally, let's do it in green. We've taken what we had originally, which was in the ax squared plus bx plus c format, and by completing the square, we've changed it into the a x minus p squared plus q format. Okay. Now, we said that the a didn't change in both formats. So the a in the first standard form and the a in the second standard form remain the same. They have the same impact or the same influence on the graph, okay? But as we said, the other variables are different. That was a b and that was a c, which means something very different to these two variables here, which is a p and a q. So what we want to now try and do is work out what exactly are that p and that q doing? What do they represent in your parabola? Well, in order to explain that, let's go back to the original equation they gave us, which was 2x squared minus 4x minus 6. Okay. Remember that because we've got a bx term in that equation, it means that we're going to, our axis of symmetry is going to shift, okay? Because it's a minus 4x, we know our axis of symmetry is going to shift to the right. Remember, it always does it in reverse, okay? So it's going to shift to the right, and we needed to work out what that new axis of symmetry was, all right? So that's what we're going to do over here. So I'm going to do it in blue. I'm going to work out the axis of symmetry of this graph, which was negative b over 2a. Remember that formula? So negative b, which is negative 4 over 2a, is landing up giving me a positive 4 over a positive 4, which in fact is 1, all right? And in order to then determine the coordinates of the turning point, I'm then going to substitute that value of 1 into the x's of your original equation, all right? And what is that giving me? I'm getting 2 minus 4 minus 6, which is giving me negative 8. So the coordinates of the turning point of your graph we've managed to establish are 1 and negative 8. All right, so what's happened is the graph, the axis of symmetry moved 1 unit to the right. So there's your x equals 1. And then your y coordinate of your turning point moved all the way down to negative 8. So it moved sideways and it moved down. And that's how we got to that new turning point. Now, let's have a look over here. Do you notice that this negative 1 over here and this 1 over here are the same, except obviously we do notice that one is negative and one is positive. We're going to deal with that in a second. And then this value over here is negative 8 and this over here is negative 8. Aha. So this p-value, this negative p-value and this q-value are actually representing the shift sideways, the horizontal shift, and the shift downwards, the vertical shift that was happening in this graph, which actually landed up taking us to the turning point. Okay, so the p and the q, when we have it in the form of y is equal to a x minus p squared plus q, what do this p and this q help us to see just at a glance? They are helping us to determine the coordinates of the turning point by telling us what the horizontal shift and the vertical shift is of the graph. And that's what the p and the q are representing. So the negative p and the q are the coordinates of the turning point. Now let's quickly just address the negative p part, okay? Let's take this over here. So we've established that the coordinates of the axis of symmetry is x equals 1, all right? If I were to move that 1 back over the equal sign, do we agree we're going to land up with x minus 1 equals 0? Now, if I were to, so can you see by putting it back into a set of brackets, we get x minus 1, all right? So remember that this x, you're not just solving for p, it's x minus p, and that's why when you're solving it you have to actually almost make that bracket equal to 0 and solve for x, and by doing that the x is actually moving over the equal sign and as a result changing sign. So please remember that whatever this p value is, this negative p, it always changes sign as a result of solving for the x. Okay, the q, no, the q does not change sign, but the p does. All right, and so just watch out for that. That's a standard thing. It happens with all of the graphs. All right, so the negative p is representing the horizontal shift. Where is your axis of symmetry moving, to the left or to the right? The q represents the vertical shift. How many units up or how many units down is that graph moving? Please do not make the mistake of thinking that the q, so this q over here, does not represent the y-intercept. It is only when it is in the form of y is equal to ax squared plus bx plus c. Remember, the c value is the y-intercept. So -6 is your y-intercept in that standard form. But when we convert it to this standard form, remember that this is no longer a b and a c, it's a p and a q. The negative p is the horizontal shift and the q is the vertical shift. And together, the p and the q form the coordinates of your turning points. Okay, so what's really handy about having it in the equation of x equals y is equal to a x minus p squared plus q is that at a glance you can see what your coordinates of your turning point are. Very handy. All right, but there we go. That is then the two different standard forms in which you can find your parabola equation, and you need to be familiar with both of them as well as being familiar with how to convert it from the one format to the other. All right, okay, so now that we've dealt with that, we are now going to take a look at sketching your parabolas. Okay, so join me in the next video where we're going to take different examples of parabolas in both the two different types of standard equations and what are the steps that we follow to actually properly sketch a parabola. I'll see you there.